So we can match these graphs to these equations by looking at a few properties. Okay, so the first thing that we're going to look at, let's take a look at this one here, the first one. And we can see that this parabola opens up and has a y-intercept, looks like it's just under 0 there. And so what we can do is we can look at these equations and look at the leading coefficient and see which one opens up. Okay, so what we're going to look for here is a positive A coefficient. Okay, so it's opening up in this direction. Okay, the other thing is that the y-intercept in this case is -1. Okay, and it matches that one there. So this one definitely is B. So these are all in the general form equation, which means then that essentially we have two things that we can look at, the leading coefficient and the y-intercept. The B value, if you're really good with these, you might be able to interpret something with the B values in relation to the vertex, but we're going to leave that for now and look at that as a more advanced property. So if we look at that next graph, okay, that next graph definitely has a negative A coefficient. So it's pointing down. Okay, it's opening down. And so it could be either one of A or C. However, when we look at the y-intercept here, the y-intercept is -3. The y-intercept here value is +4. The y-intercept value is -3. This one matches. Okay, so this is one we're looking for. So it certainly doesn't match A. Okay, so we're going to say here the y-intercept value is equal to -3. And for the last one there, well, there's really only one choice left, but we can still look at the properties here. It's got a negative A value. Okay, it's opening down. Okay, and the y-intercept here is going to be at +4. Okay, and we can see that, yeah, this one's opening down and also has a positive y-intercept. And so we can say that these ones, the A matches this one here, and we didn't label it, but the C equation matches the middle graph here. Okay. So for these general form equations, we're looking at two main things, the direction of opening and the y-intercept. So what are these properties of graphs that we can look at? Okay, so we want to be able, the big one's the vertex. Can we relate the vertex to some part of the expressions? Okay, well, the vertex is P and Q in the graphing form. How can we relate it to the other forms? Well, there's something called Vieta's formula. Okay, and Vieta's formula relates to general form, and it basically tells us where the middle is. It tells us where the vertex x coordinate is, P. It tells us that by taking the -b over dividing it by 2a, and that finds the x coordinate of the vertex. And this is very useful. So if you've never seen this, you might want to make note of this because this is a very useful formula. The other thing that we can make note of between the different forms is the A value. The A coefficient is the same for all three forms. Okay, so it's the same for all three forms of the quadratic function. Okay. Another way, and again, really the big key is the middle coordinate, and we can maybe even come up with another one here. The middle coordinate, based on the root form or the factored form, we know that the middle coordinate is going to be halfway between the two zeros. Okay, and so if we take the zeros m and n and divide by 2, we can get the middle that way. Okay, so the middle is the average of the two zeros. And average really means middle. Okay, and anytime we see average, it's really the middle between two coordinates. It's the average between the two zeros. In fact, not just the two zeros, it's the middle of any two symmetrical points. Okay, so these are some properties that we can relate the different parts of the equations to each other with. And as we come up with more, we really should make note of them, right? But these are some key ones, especially these two here, the Vieta's formula, okay, and this being able to find the middle based on the roots. These are very useful properties.